Welcome back. So let me finish this. I just have a few slides to go, maybe 10 slides left. So this is here to show you the difference between the case when I have flat and homogeneous data sets of JSON, meaning only atomic values, nothing nested, and all the values are all the keys are always there. And the other extreme is that it's nested and heterogeneous, but to a point that it doesn't always make sense to even draw it anymore, right? So here I try to draw a little bit. So what I wanted to show you is this, where you have an object and a string in an array, right? They don't have all the same data type. And so I attempted to draw it in this way. But you really need to see these two cases, flat homogeneous, nested heterogeneous, and data frames are somewhere in the middle. They are somewhere in the middle where you still have a bit of structure. Now, this is a syntax that's JSON. This is another syntax that's XML, but in the end, these are all trees, right? This is what matters. And there's plenty of other syntaxes. I put YAML in there, but there are also the data frames that's more of a logical construct on top of that for valid JSON. CSV in the case that it's flat and mostly homogeneous. Avro and Parquet, what are these? These are binary formats that can save a data frame together with its schema. A data frame always have a schema. And so you can technically, and this is what people do in real life, you can download a JSON data set from the internet. Takes a lot of place, but it's textual. And then if you see that there is a structure, the first thing you should do if you intend to query it a lot is to create a schema, instantiate a data frame with RumbleDB, with Spark and so on, and save it back as Parquet or Avro or a format like that. Why? Because the size it will take on disk will be much less than JSON. That's the power of validation. You can compress your data. And when you have less bytes to read from disk, it means that your querying will be much faster. Remember that the bottleneck, as we will see for MapReduce and others, is reading from the disk. So if the files are smaller and you still have the same data in less space, it's very beneficial. And so we'll do it in the exercises. We'll show you how you can take a JSON data set, validate it, put it in a data frame or let it be done automatically by the software and save it as Parquet. And then you can directly read the data frame from Parquet instead of reading it and validating it from JSON. For whom does that make sense? Right? It's super useful. That's really data engineering at its best, right? The idea that you save your data sets, if it's valid, to much more efficient formats like these. Protocol buffers is a bit similar. It's kind of the Google version of these, if you want to put it that way. It forces you to create a schema somewhere, but you can then instantiate this to C++, to Java, to Python in a way that you can programmatically access the data that you saved, right? So the difference really with JSON and XML is that there is no text in there. It's really just saving and loading the data frames from disk, but without any text. Okay, so now you see how this is all related, the notion of textual syntax, XML, JSON, YAML, validating this, creating a data frame, and then the ability to save that to a binary format instead of a text format to be much more efficient, right? So there are these three dimensions if you want to kind of look at this ecosystem, because there's many more than these. Is it nested or is it flat? CSV, for example, is not nested. Is it text or binary? JSON is textual, Parquet is binary. Is the schema required or optional? In JSON, it's optional. In Parquet, it's required. So is it in protocol buffers and so on. Okay, now speaking of which, what I want to show you now is it's not new material. What I want to do here is show you that with what we've learned in this lecture, you can very easily look at any one of these formats and you will immediately understand it. You might need to look at the documentation for the exact type names that they give, but it's the same. So what I did here is I took Parquet and I just listed the atomic types. Why should you not be surprised by this? Because even though the names are different, it's pretty much what we've already seen, right? There's a Boolean value in 32, 64, right? Int and long in Java or even in JSON and JSONic. They have an int 96. No, that's very original, right? But why not, right? That also makes sense. So you see, you can have extra types you haven't seen before. Double, we've seen it. Decimal, we've seen that too. It's also in PostgreSQL, and it also exists in JSON and JSONic. Strings, UTF-8, they call it UTF-8, but that's really just a string. They actually specify the encoding. You can have enums. Now that we didn't have in JSON and XML, but it's an enum is just a constant enumeration of possible values, right? For example, if you want to model traffic lights, then that's going to be red, yellow, and green, right? Okay. Now binary is also a type. We had hex binary and base64 binary in XML and JSON. The date should also not surprise you. So these are the atomic types. But basically, you don't need to learn that by heart. The only thing I want to show you here is you've seen it all. That's it, right? Any technology, you look at this, you can map it in some way to what you already know. The same here for the structured types. They basically have lists and maps. It's the name of the extract types. Well, this is basically an array that's basically an object, right? So whenever you look at these technologies, you will see it will be very easy to learn for these reasons. You already have the general ideas, the general structure. It will only be about some extra types that you might not have seen before, some different names given to the types and so on, but that's the idea. This is now the protocol buffers. That's the syntax for the schemas. But you see, you will have no difficulty understanding what kind of data frame this is, right? Because you have a person, required string. It's like the same as the exclamation mark is in JSON. A repeated string, so that's similar to XML where you can repeat the elements. You have an optional title and an optional person that goes recursively through it, right? So this, anybody should, from what we've learned, kind of make sense of what that means. I'm not asking you to learn the syntax by heart. I'm just showing it to you to show you that this is some example of how it can look like, and now you know how to process it.
We had the question at the end of the last lecture, right?
Oh, yes. Let's go to you. Where were you? Here, exactly. I can be distracted sometimes. So let's take your question.
So on like some slides before this one, with the nested heterogeneous data.
This heterogeneous, this one.
Yeah, this one.
Yep.
So you say that it doesn't have a schema. Does that mean schema in the relational database kind of schema, or does it mean no schema at all? Because I think we could also construct a JSON schema for that kind of data.
Absolutely. So let me be even more precise on this. What I meant here is that in order to draw that, I don't need a schema. I might have this JSON data right there, no schema at all, and I can still attempt to draw something like this. But what I'm saying is that if you just have some random JSON that comes out of nowhere, it might be messy, don't have any schema, and then it's highly nested and heterogeneous, right? Now, it doesn't mean you cannot build a schema. In fact, you might still be able to build a schema. For example, I could do something very high level, like ID is an integer, profession is a string, and people is an array of items, and comment is a string, right? So you will always find a way. You can even technically create a schema that has no key at all and say it's open, you can accept anything. Then that is a schema that accepts everything. So you will always be able to do that. The question is, can you create a schema that fulfills the constraints in such a way that you get something like this, right? You will not get that with all schemas. You really need the schema to have a closed object type, only instantiable types, and so on, right?
Isn't another requirement that it's very strongly ordered, the schema? Because we need to ensure that the columns have the right ordering.
Technically, yes, we assume an order here, but it's not in the semantic. So technically, if I would swap, put living before who and so on, semantically, based on the fact that we have objects and the keys have no order, the order is not important in that case. But in the array, it is, right? But this is part of the semantic of an array, right?
Thank you.
Does it make sense?
Yes.
Okay, awesome. So, this is the concluding slide of this lecture, where I want to wrap up things saying now you can take a collection of JSON documents and you can look at it in two ways. It can be fully heterogeneous in the sense that it's a mess. Maybe it's something that has been accumulated over 10 years or 20 years with different structures. But what you can do is try to fix it. Maybe you can modify it in such a way that will make it more structured. Then you take a schema, you build a schema, validate it, and then you get something that is more homogeneous. And if it's super homogeneous, then it can be to a point that you can have a data frame and save it efficiently in a good binary format, right? So both are part of real life, right? This is really raw data that might have been accumulated. And there is a whole discipline on how to clean that up and transform it into something more homogeneous. For example, for machine learning, right? If you want to feed it into some machine learning algorithm, all right? So I won't teach you how to clean up, but I will teach you the tools that can be used to clean it up, right? With a query language. Okay, any more questions to finish this lesson? No more questions? All right. That was the last lesson strictly on storage and formats and so on. Now we are moving on to querying the data, and we are going to look at MapReduce. It seems that we'll have some time today. So I'll see you on the other side of the recording.